All right. In this problem, we are going to try to find the measure of this inscribed angle. We have two congruent rectangles in a semicircle, and we're trying to find the measure of this angle. If you want to solve this on your own, pause the video because I want to solve it in just a few seconds. Okay, let's go. Okay, the first thing I'm going to do is I'm going to draw the diagonals in of these rectangles, and I know that the diagonals of the rectangles must be congruent because the rectangles are congruent. Now that I drew the diagonals in and marked them off as congruent, I'm going to draw another segment from the bottom of those diagonals. So now I drew that segment in. Now what we have here is an isosceles triangle. Now one of the properties of an isosceles triangle, here let me get an isosceles triangle drawn for you. Now one of the properties of an isosceles triangle is if you drop the altitude down from the vertex angle, that is going to be 90 degrees, but also bisect the base. So now what I'm going to do is I'm going to drop the altitude down in this isosceles triangle. So here's our altitude on the isosceles triangle, bisects the base. And this brings up an interesting property of a chord in a circle. If you have a line, which is the perpendicular bisector of a chord in the circle, like this is over here, then that guarantees that this perpendicular bisector is the diameter that goes through the center of the circle. So since this is a half a circle, this line coming down is part of the diameter, so that guarantees that this point right here is the center of our circle. Now that we established that this is the center of the circle, we can clean up some of these images to give us a little bit of room to work. All right, now let's focus on these rectangles. The angles in a rectangle are all going to be 90 degrees. So these angles up here, let's call this one X, let's call this one Y. This is an alternate interior angle, so that has to be X. This one over here is going to be Y. We rotate this around, flip it up on its edge. This Y is going to end up here. This X is here. Alternate interior, alternate interior. And what we notice is up here, X plus Y is equal to 90. So if X plus Y is equal to 90 up here, then that means X plus Y is equal to 90 here. Makes this a 90-degree angle. Okay, let's clean it up a little bit, which leads us to another interesting property in a circle, is that concept of a central angle. Whatever this angle measures here, the intercepted arc also measures up here. So what that means is now if I draw this arc in, connecting the ends of those diagonals, that arc is going to be 90 degrees of the entire circle. Now what I'm going to do is I'm going to bring the circle back in. So a circle measures 360 degrees, makes this arc here 360 minus 90 degrees, which is going to be 270 degrees. Which brings us to another concept in a circle. The next concept of the circle is going to be the inscribed angle. And the inscribed angle is half of whatever the intercepted arc is. So if this is X, this here is going to be 2X. Looking at it conversely, if this is X, this is going to be 1/2 of X. So now our purple arc is the intercepted arc for this inscribed angle right here, which makes that angle equal to 135 degrees. Now that's a pretty cool problem. So if you enjoyed this video and would like to see more, please smash that like button and subscribe to my channel. I'll see you on the next video.